Hello guys, and welcome back to another episode of Blocks Aren't Bad. Again, this is the Nightmares, where I'm specifically Phillip Nguyen, going to be teaching you how to make a basic drive teleop. Now this is assuming you have Mechnim wheels, and so let me show you what that should look like. Just pull up our main teleop. Oops, I need a connecting controller. Anyway, should look something like this. We have the forward, backward, the left and right, and then the turning. So I'm going to be showing you how to code that onto the robot. It's actually quite simple. Though this will not be, there are not going to be any servos or anything. It's just going to be drivetrain. Alright, so get rid of all the comments. Alright, so the first thing to do is let's think of each aspect as its own variable. So we need forward, left, right, or I guess strafe, and turn. Each of these has its own joystick. I mean, at least for us, this is forward, backward, this is left, right, and then this is turning. So, first instinct, especially like my first instinct, is to always just take whatever gamepad element. Like if you want to do forward, that's left stick up and down, kind of like in video games. And then take the motors. And set them all to forward. Wrong one. Alright. But if you notice, this isn't going to work, because two of the motors are backwards. So when I push up, they should move forward. But if you notice, the right side of the drivetrain is moving backward. So we need to reverse that in code. Now there's two ways you could do this. There's kind of like the bootleg way of doing it, where you just take negatives and put them before here, like this. But the more like quote professional way of doing it is to go to actuators, and then find this block, set direction reverse. We need to set the right side of the drivetrain to reverse. So there we go. We can just put that here. Alright, so now it goes forward and backward just fine. So let's try adding turning to it. So you're probably thinking, oh, all we have to do is just do this, set this to turn, probably add some negatives, and then it should work. There is a problem with doing it like this. If you notice, if we just do this when we drive, I don't know if you can hear it, though also I didn't make the variable, so. You'll notice that it's a little bit choppy. I don't know if you can tell just by looking, but it is certainly choppy, and I also put the negatives in the wrong spot. But it'll drive, but it's certainly choppy. I'm sure you can even hear it. It's very hard to tell with just two things, but like, let's say I then added strafe to this, which I don't know what the minus negatives would be. Maybe this. Let's just guess. Let's see if this is right. But as you can see, it is very slow. Like, see, this is me driving forward full speed. That's me turning full speed. And it works, but like, notice that now if I take all this other stuff out and just do forward, how it drives. Well, I can't turn, but how am I gonna get the robot back? The idea is that if we just set everything like this, number one, it looks kind of weird, And number 2, keep in mind that whenever you're not touching, let's say I wanted to go forward. If I'm driving forward, that means that this is equal to, not that, this would be equal to, come on, 1, while these are all equal to 0. And so that means we have something telling the motors to go to 1, and we have something else telling the motors to go to 0. So like, what the freak am I supposed to do? And so it just makes this overlapping, and it causes the motors to stutter as they move, which makes it slower. So this is a common mistake that pretty much every single new FTC team makes, is they don't consider for overlapping. So I'm going to show you how to fix it. Keep in mind, pay attention to where the minus and negative values are at. There's something neat we can do with the math function. So take one of these, and you want to put the forward and the strafe in the same mathematical function. That's because they're on the same joystick. And then generate another plus for the turn. And then just copy it all to them. I gotta move this. Sorry. Copy it over. And so the reason for this is because now whenever these are 0, it's not affected by it. But we need to assign the correct minus values to each one. So let's see. For front left, this needs to be minus. For front left, this needs to be minus. For back left, this needs to be positive, minus, positive, 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 or minus positive. So, in theory, now this should work a lot better. As you can see, it's working just fine, and it's driving at full speed. And we could actually make this a little more complicated if we really want to. So it is technically possible for the values to exceed or go below a certain amount using, or you could set limits on the min and max using, well, min and max. It's a little strange though. Let me explain. So the max operator, let's say I have two numbers, 10 and 16. Well, the maximum, when you run this, the return will be 16 because that's the highest of the two numbers, and vice versa. If I run this, the output will be 10 because that's the minimum. So if you do something like this, where you make a variable called minimum power, maximum power, and let's say we want the max to be the minimum to be negative 0.5, and we want the max to be 0.5. So now what we do, it's a little counterintuitive, but you'll take the maximum value and put it in the minimum. And the reason for that is because if, let's say this is the power, if it ever exceeds the maximum, it just goes like, let's just say since the max is 0.5, if anything ever exceeds 0.5, like let's say this is 500, it's just going to return 0.5 because it's the smaller of the two. And vice versa, you take the minimum for here. And so you want to do something like this. So say for example, let's say that we input the value 10. Well, 10 is above the maximum, so 0.5 is returned. Let's say we return negative 10. Well, negative 10 would go through here because it's smaller, but when it goes through here, negative 0.5 is returned because that's the larger value. So that's how this works for your drivetrain. So if we just copy this a bunch of times, what did I just do? Oh wait, no, hold on. This goes here, and then here. Why do I keep deleting it? What am I doing? Alright, this goes here. That goes there. And so now, in theory, it should only run at half power at most. And I don't know. I don't know if it's very noticeable. So let me change these values. to like something smaller, like 0.3. As you can see, it's much slower now. If you do something like this, the movements are also a little less precise because anything you do will cause it to go past the range. But that's that for it comes to maximums. I'm just going to put it at 0.5 so I don't drive it off the table. There's one other thing we could do. I'm going to show you how to do functions for this. So, brake and float. This will make sense in a second. So, there's something called zero power behavior in the motors. What that means is, what should I do when there's no input? And so there's brake and float. So I'm just going to show you. I think it'd be easier to show you with words. Let's make it to where A. Okay. So that was a little fast, but I'm going to break it down. So I made two functions, one called brake and one called float, where when we call this function, which is when we press A is when we call it. Again, this is how you call a function. This is how you make one. When we call the function, it sets all the motor's brake behavior to brake. And then when we press B, it calls float, and that causes them all to float. So let me show you the difference real quick. So this is with brake mode on. Notice the way that the motors are making an effort to stop. And then this is float. The motors just kind of don't care about it, and they'll just keep going. And that's the main difference there. And so if you, let me think, what else could we add to this? That's pretty much it for when it comes to basic drivetrain. There's not really much else I can talk about, so thank you for watching and stick around for the next one.